Hello everybody, welcome back to the channel, and this is the second video for AS level Pure Math at Excel, where I'll be covering chapter 2, which is Quadratics. So we'll start with 2.1, and we'll begin by looking at this, ax squared plus bx plus c equals 0. Alright, now all quadratics will always be able to take this form, where a, b, and c are constants, and x is the variable we're trying to solve for. Alright, so all quadratics will always be able to take this form. Now, there are three ways that we can solve quadratics, alright? So the first way is by factorizing. The second way is by using the quadratic formula. And the third way is by completing the square. Alright, and we will be looking at all three of these methods in this video, starting with factorizing. So we'll start with factorizing, and then we'll go on to using the formula, and then we'll go on to completing the square. Alright, so let's begin. So let's begin with factorization. I've got 4 questions here. So let's begin with part A, right? So we've got x squared minus 2x minus 15 equals 0, right? Now we covered factorization in the last chapter, so if you don't know how to factorize quadratics, do go and watch that video, because in these questions I'm just going to be doing it really quickly and not really explaining the process. But if you need an in-depth explanation, do go watch the previous video. So in this case, we want two numbers that multiply to this, and the same two numbers that add to this, which in this case are minus 5 and 3. So we're gonna write that, write that in our brackets. So x minus 5 and x plus 3 equals 0. So how can we solve for x? Well, what we want to do is we want to divide both sides by one of these brackets. So let's say we pick this bracket. Then we divide both sides by x minus 5, which means we'll have x plus 3 remaining on this side, and we'll have 0 over x minus 5 on this side. Well, what can we do here? This x plus 3 will stay the same. However, this 0 over x minus 5, we know that this will always be 0, right? Because 0 over anything is just 0. So we can just write down 0 instead of 0 over x minus 5. And then we can solve for x. Bringing the 3 over to the other side will give us x minus 3 as our first solution, right? And then we want to do this for the other bracket. So now we're going to divide by x plus 3 instead of x minus 5. And that will leave us on this side with x minus 5 equals 0 over x plus 3. Now again, this x plus 3, 0 over x plus 3 is just the same as 0, right? So we can write x minus 5 equals 0. And then we can bring the minus 5 over, giving us x equals 5. And then we want to write our final answer, which is just that x equals minus 3 and x equals 5. So you can just write it like this, x equals minus 3 comma 5, to show that these are the two possible values or two solutions for x. So let's look at b now, which is x squared equals 9x. X squared equals 9x, right? So again, the first step is we want this side to equal 0, right? So let's subtract 9x from both sides. We have x squared minus 9x equals 0, right? So in this case, we don't have a c term, or a term without any x's. So what we can actually do here is just bring an x out, and then have x minus 9 equals 0. And if it helps you to visualize it, you can write this x in brackets as well so that you've got the two brackets if it's easier for you to think about it like that. So we've got our two brackets here. Now we want to equate both of these brackets to 0, right? So let's start with x. We've simply got x equals 0. We've equated this to 0 by bringing this x minus 9. We've divided both sides by x minus 9, giving us x equals 0. Then if we divide both sides by x to find the other value, we have x minus 9 equals 0. And that gives us x equals 9 if we add 9 to both sides, which means we can write that x is equal to 0 or 9, right? So that's it for part B. Let's look at part C. 6x squared. Oh, I did not read the entire thing. 6x squared plus 13x, I believe. Yep, 13x minus 5 equals 0. So in this case, it's already equal to 0. And now we want to find, we want to know how to factorize this, right? So first things first, we'll multiply this by this, which will give us minus 30. And we want two numbers that multiply to minus 30 and add to 13. And those two numbers are minus 15 and 2, right? So let's just write that out. 6x squared, minus 2 and positive 15. So minus 2x plus 15x minus 5 equals 0. Again, for more in-depth explanation, watch our previous video. Then we will take the 2x out, leaving us with 3x minus 1. And then here we will take 5 out, right? Plus 5, leaving us also with 3x minus 1 equals 0. And then this and this will make our first bracket. So 2x plus 5 is our first bracket. And then the second bracket is just these two brackets, which should be the same, which in this case they are. So we know we've done it right. So 3x, so this is, or 3x, so 2x plus 5 times 3x minus 1 equals 0. This is our quadratic factorized, right? So now we want to solve for both of these brackets, right? So let's start with this one. We can just equate it to 0, so 2x plus 5 equals 0, which means if we bring this 5 over, 2x equals minus 5. And then if we divide both sides by 2, we have x equals minus 5 over 2. So this is our first value of x, or if you rather write it in decimal, minus 2.5. So this is our first value of x. Then we use our second bracket. So to find our other value of x, 2x minus 1 equals 0. And then we add 1 to both sides, so 3x equals 1. And then divide both sides by 3, giving us x equals 1 over 3, or 0.3 recurring. So these are our two values of x. So let's just write that out. X equals, and I prefer to write it as fractions because it's just easier to interpret and write into your calculator if needed. Like for example, if you wanted to write 0.3 recurring into your calculator, you're not going to write an infinite number of threes, so it's just easier to write 1 over 3. So I prefer to write it as brackets. And yeah, those are our two values of x for part C. Now let's move on to part D, which is, I'm not going to remember all of that in one go. D is x squared minus 5x plus 18 equals 2 plus 3x, I believe. Yep. Right, so part D, right, so part D, first things first, we want this side to equal 0. So we'll bring the 2 and 3x over. So basically we're subtracting 2 on both sides and subtracting 3x on both sides. So the x squared will remain unchanged. Since we're subtracting 3x on both sides, that will give us minus 8x over here. And since we're subtracting 2 on both sides, we will get plus 16 over here. And that will just give us 0, right? So the two numbers that are going to multiply to positive 16 and add to minus 8 are minus 4, right? So we've got x minus 4 and minus 4 is what I meant to say, sorry. So in this case, the brackets are the exact same. So we can rewrite this as x minus 4 squared, right? Now in this case, it doesn't matter which bracket you divide by, you will always get the same answer, which in this case, if we do it out, x minus 4 equals 0 and x equals 4, both brackets will give you x equals 4. So this quadratic only has one solution as opposed to the other two quadratics which had two solutions. So that's the difference. Some quadratics will have two solutions, some quadratics will have one solution, and some quadratics may even have 0 solutions. So yeah, just be wary of that, because some quadratics may not have two numbers, or two real numbers at least, that multiply to this number and add to this number. You might have to use imaginary numbers, but don't worry about that. Just know that some quadratics have can have two real or two answers. Some will have one answer and some will have no answers at all. So in this case, we only had one answer for x, whereas in the previous cases we had two. Now let's use the second method for solving quadratics, which is simply just using the quadratic formula. Now, the quadratic formula is minus b plus or minus the root of b squared minus 4ac all over 2a. This is the quadratic formula. Now, if you remember the form that we write quadratics in, it's ax squared plus bx plus c. Plus c equals 0, right? So this a, b, and c will actually correlate into this formula. So in this case, we've got 3x squared minus 7x minus 1. So let's just write that down. 3x squared minus 7x minus 1. And we can see using this that the coefficient of x squared is a, so we know that a equals 3, right? Because this is our a. Then we know that b is minus 7, so we can write that down. B equals minus 7, and we can see that c equals minus 1. So we've got our a, b, and c. Now all we have to do is just put them into this quadratic formula. So let's do that. Let's start with minus b, which is just 7, plus or minus b squared, which minus 7 squared is just 49, positive 49. And minus 4ac, let's just write it as minus 4. We've got a, which is 3, and c, which is minus 1. So let's just write it out like this for now. We'll simplify it in a second. And then that's all over 2a, and a is 3, so we can multiply that by 2, giving us just 6. Now let's simplify this part. 7 plus or minus root 49 minus, 4 times 3 is 12, times minus 1 is minus 12, and then minus 12 is plus 12. So we've got 49 plus 12. All right. And then that, again, is all over 6. Then we've got 7 plus or minus root of 49 plus 12. Well, 49 plus 12 is just 61. So we've got 7 plus or minus root 61 all over 6. And those are simply your two answers. X equals 7 plus or minus root 61 over 6. You can write this as a decimal if you'd like, or you can write it as like this. X equals, you can write the term separately, so you can write 7 plus root 61 over 6, and 7 minus root 61 over 6, right? So these are the two ways you can write it. You can write them as decimals, but I wouldn't really recommend that. It's better to just give the exact value unless the question asks to 3 decimal places or 4 significant figures or something like that. I would recommend just writing it in its fraction form. And that's how you use the quadratic formula. So now we'll move on to the third method of solving quadratics, right? And that is known as completing the square. Now, for completing the square, it's actually part of 2.2, not 2.1, so we are moving on to 2.2 now. But this is the third method for solving quadratics. So the first thing you want to know is that, let's say you had x squared plus bx, right? For completing the square, this can be rewritten as x minus b over 2 whole squared minus b over 2 whole squared. So this might look a little bit confusing right now, but I assure you it will make sense when we start doing questions. So let's look at the first question. So let's complete the square for these expressions, right? Here, let's start with A. We've got x squared plus 8x, right? So let me explain the process of how we got to the formula that I showed you above, right? So what they did is they, first of all, took x out here, but they didn't write it outside. So they basically divided this by x and divided this coefficient by 2. So they basically had x plus 4 because we've divided by x and divided by 2. And then they squared this entire bracket, right? So that's the first thing they did. The second thing they did is they took this term and subtracted the square of it. So 4 squared is 16, so they basically subtracted it on the outside and got minus 16. And that's all. That's how completing the square works. You just divide this by x, divide this by 2, and then take the square of this and subtract it. So that might have been a bit confusing. Let's do this one, right? Let's take b, right? So again, we've got x squared minus 3x. So let's complete the square. We divide by x, so now we've just got x, and then we can divide this by 2. So minus 3 over 2 whole squared, right? Now we want to subtract the square of this, which is just 9 over 4. So we take that outside and subtract it from the entire thing. And that's it. That's like how completing the square works. Now, in this case, we've got a coefficient in front of the x squared. And when we have that, it gets a little bit different. We want this we want the coefficient of x squared to be 1 in all cases. So what we're going to do is we're going to take 2 out first. And we're going to write x squared plus 6x and close the brackets, right? So all I've done is I've taken 2 out here. Then we can complete the square for this. So we can say 2 x, we divide by x, and then we divide this by 2, giving us x plus 3x here, whole squared. Now, in this case, wait, let's write it like this. This whole squared minus 3 squared, which is 9, so minus 9, and close the brackets. So we don't want to leave it in this form. This bracket is okay, but we want to take this out of the bracket. So we basically write this 2x plus 3x squared, right? This does not change, but we're taking this minus 9 outside the bracket, so we need to multiply it by 2, giving us minus 18. And now this is outside of the bracket, and we've completed the square, except now we've got a coefficient, but it doesn't matter. If you've got a coefficient in front of the x squared, you just want to take it out so you don't have to deal with it. And that's how you complete the square. Now say we have this. Now this is a little bit different. We've got a C term now. So it doesn't really change much. It's just, it might get a little bit confusing or daunting to look at when you see it for the first time. So we'll start out by writing it, right? We can just ignore this for now. We're going to complete the square. If I draw the brackets here, we're just going to complete the square for this and ignore this for now. So let's take the 3 out first, right? Because we don't want a coefficient in front of the x squared. So we take that out, and now we've got x squared, now we've got x squared plus 2x plus 1, right? We're not going to consider this for now. And then we want to complete the square for this, which will give us 3 x squared plus x, as we're dividing this by 2. Or wait, what am I saying? X plus 1, sorry, because we're dividing by x and by 2 for this coefficient, sorry. And then we're squaring this, and then we want to subtract the square of this, which basically gives us -1. And then we've got our +1 on the outside. Now we want to bring this -1 outside the bracket, so we need to multiply it by 3. This does not change, so we have x plus 1 squared. Now this we're multiplying by 3, so we've got -3 plus 1. And now we can consider this because we can just collect these two together to give us -2, right? So we've got 3x, 3 times x plus 1 squared, -2. And that's how you complete the square when you've got a C term. And that's it. Like, it really does not get simpler than that. Or harder than that, rather. Sorry. It is simple. It doesn't get harder than that. So now, let's look at actually completing or solving for x using completing the square. So let's complete the square for this first, right? So let's just write it out. Now when we're solving for x, we want to make sure that this side is 0, which in this case it already is, so no problem. Now we want to ignore the constant outside and only focus on this part, right? So we've got a coefficient in front of the x, so we want to get rid of that. So we take it out, and we're left with x squared minus 4x, and this plus 7 on the outside equals 0. Then we want to complete the square for this, giving us 2x squared, or not x squared, we're dividing by x and dividing this by 2, so x minus 2 squared. And then we want to subtract the square of this, so minus 2 squared gives us positive 4, which when we subtract gives us minus 4, plus 7 equals 0. And of course we want to take this out, so we have 2x minus 2 squared. And since we're taking this minus 4 out, we need to multiply by 2, giving us minus 8 plus 7 equals 1, or sorry, equals 0. And then we can collect these two together to give us minus 1, because minus 8 plus 7 is just 1. So this doesn't change. Minus 1 equals 0. Now we want to solve for x, and since we've got this side equal to 0, we can first of all write this out again, and what I'm going to do is I'm going to add 1 to both sides to get rid of this. So we've got this is equal to 1. Then we can divide both sides by 2, giving us x minus 2 squared equals 1 over 2. Then we want the square root, we want to square root both sides, giving us x minus 2 equals the square root of a half. Now, be careful here. Whenever you square root anything, this can be plus or minus, because think about it like this. Let's say you had minus 2 and 2. When you square minus 2, or when you square 2, you've just got 2 times 2 equals 4. And when you've got minus 2 times minus 2, well, these negatives, because there's an even number of them, they will cancel out to a positive. So this will also give us 4, which means when we're writing the square root of 4, it can either be positive or negative, because it could be positive 2 or negative 2. So whenever you're squaring a number, you want to make sure that you write that it could be positive or negative, right? So yeah, just be careful or mindful of that. Now we've got plus or minus root 1 over 2. Then we can just move the 2 over, so add 2 to both sides, giving us, whoa, my mouse, 2 plus or minus root 1 over 2. Now we've got this, x equals 2 plus or minus root 1 over 2, but we're not done just yet. If you noticed in the question, it said give your answers in surd form. And this is not in surd form. This can be simplified. How? Well, let's rewrite this. X equals 2 plus or minus, well, using our laws of indices, we know that root a over b equals root a over root b, right? So we covered this in the last chapter, but this is one of the laws, and in this case we have that. So we can rewrite this as root 1 over root 2, and the root of 1 is just 1. So we can simplify that even further to just have 1 over root 2. Now this is already in surd form, so this can be our final answer. If you want to go even further, you can rationalize the denominator, which again is something else we covered in the last chapter, but it's not exactly necessary. I mean, I'll do it anyways just because. We're basically just going to multiply by root 2 over root 2, which will give us root 2 over 2, right? So you can rationalize the denominator if you wish, but this is already good enough because it's already in surd form. But either of these two is fine as your final answer, and that's how you solve quadratics using completing the square. Now let's move on to 2.3, which is functions. Functions are really simple. They are represented by f bracket x bracket, f bracket x, right? And how you say this is f of x, or the function of x. Now let's say this is equal to 5x plus 2, right? What this basically means is for any input of x, the output will be this. So let's say we input 1 for x, right? Let's say x equals 1. We replace x with 1, and we, in the function, anywhere that it says x, we are replacing that with 1, right? Which means that this f, or 5 times 1 is 5. The plus 2 does not change, and that gives us 7. So that means when you input 1 for x, you get an output of 7. Now, the range of possible values you can input is called the domain, and the range of possible values you can get as an output is called the range. So why is there a range of possible values? Couldn't you put in any value and it would work out? Well, not necessarily. Let's say you had f of x equals 2 over 3 plus, or 3 minus x, let's say, right? Let's say you sub in 1 for x again. Well, you'd have 2 over 3 minus 1, right? and that will just give you 2 over 3 minus 1, which is just 2 over 2, which will give you 1, right? So that works out just fine. But what if we said f of x, where x is 3? Now we've got 2 over 3 minus 3, right? And that will give us 2 over 0. And anything divided by 0 is, well, not a real number, which means that x cannot equal 3. And that means that our range, or our domain, so the range of possible values of x, is simply that x must not equal 3. This is our range, or sorry, this is our domain. Because if we input 3, we will get a number that does not exist. We must enter a number or input a number for x that does not equal 3. This is our domain. All right, so that's basically functions, right? There's one more thing you need to know about functions, and that is that the root of any function is where the function is equal, or f of x is equal to 0, and that will give you the roots of the function. So let's take the original function. We had f of x equals 5x plus 2, right? F of x equals 5x plus 2. So let's say we want to find the roots of this function. Well, we know that the root of any function must be the function equal to 0. So we can just sub in 0 over here. 0 equals 5x plus 2. We will subtract 2 from both sides, giving us minus 2 equals 5x. And then we will divide both sides by 5, which means that the root of this function is minus 2 over 5. That is the root of this function. And that's all you need to know. You just need to understand domain, ranges, and how to find the root of a function. Now let's look at this question. The functions f and g are given by f of x equals 2x minus 10 and g of x equals x squared minus 9. Let's start with part A, right? It says find the values of f of 5 and g of 10, right? So let's write out f of 5 here, right? So we know that f of x is 2x minus 10. So since they want the value for f of 5, we're replacing anywhere that it says x with 5, right? So we've got 2 times 5 minus 10, and that will give us 10 minus 10, and that just gives us 0, right? So that's the value for f of 5. Now let's find the value for g of 10. G of 10. Now we know that we just want to sub in 10 for anywhere that it says x. So x squared minus 9, that's basically 10 squared minus 9, which is 100 minus 9, minus 9, which is just 91. So this is the value of g of 10, right? So that's all we have to do for part A. We just want to find the values of f of 5 and the value for g of 10. So let's try part B. Find the value of x for which f of x equals g of x. Now, this is simpler than it seems. We just want to equate these two functions. So f of x is 2x minus 10, and g of x is x squared minus 9. So in this case, we've got a quadratic because we've got x squared, right? So we want to move everything to one side, so one of the sides equals 0. So let me rewrite this so that we've got the sides the other way around, 2x minus 10, right? Now we want to add or subtract 2x on both sides and add 10 to both sides. So x squared subtracting 2x on both sides will give us minus 2x on this side, and adding 10 on both sides will give us plus 1 on this side, right? So what are two numbers that add to minus 2 and multiply to positive 1, well, it's just -1 and -1, or just itself. So x minus 1 times x minus 1 to factorize it gives us 0. And we can rewrite this as x minus 1 squared, which means we will only get one answer. And that answer is, well, if we get rid of the squared, we've got x minus 1 equals 0, which means that x equals 1 when we add 1 to both sides. So this value, x equals 1, is the value where f of x is equal to g of x. And you can check this by subbing it in if you really want to. So let's say we do sub it in. So let's take, we know that f of x equals 2x minus 10. And we know that g of x is x squared minus 9, right? So let's sub in 1 to both of these. Well, f of 1 is just 2 times 1 minus 10, which will give us 2 minus 10, which is minus 8. And g of x, or sorry, g of 1 will give us x squared minus 9, so 1 squared minus 9. 1 squared is just 1, and 1 minus 9 is minus 8. We get the same answer for both when we sub this value, or substitute this value of x in, which means we know we've got the right value of x, because f of x equals g of x when x is 1. Now there's one last thing I want to cover, which for some reason there are no questions like this in the book, so I'm just going to make one up. Let's say we've got f of x equals 2x plus 4, and we've got g of x equals 10x plus or minus 1. All right, let's say we've got these two functions. What would be fg of x? Now, this looks a little bit confusing, right? But basically what we're doing is we're combining the two functions together. So this is basically f of g of x. So basically what we're doing is we're subbing in g of x as x into the function f. So basically everywhere where we see x, we're subbing in g of x. So we've got f of g of x. Everywhere that we see x, we're subbing in g of x. So we've got 2g of x plus 4. And we know that g of x is 10x minus 1. So we can just write that 2 10x minus 1 plus 4. And this will give us 20x minus 2 plus 4, and that will give us 20x minus 2, or sorry, plus 2, 20x plus 2. And this is equal to fg of x. When we combine the two functions together, this is what we get, right? And be careful the order of the letters. The order of the letters does matter. If the g was first, we would be subbing 2x plus 4 into g, which would probably give us a different answer, right? So just be mindful of that. But this is how you do it. You're basically applying g of x, and then you're applying f of whatever you got for g of x. So this is how you solve when you're trying to combine two functions, and then you can do whatever the question asks you to do with this if it asks you anything. And that's basically it for functions. So now we've got 2.4, which is quadratic graphs. So let's begin by taking a look, first of all, at y equals mx plus c, right? And this gives you a linear graph, right? Which is just like a straight line, something like that. Now, what happens when we've got a quadratic graph? Well, we know that the quadratic form is ax squared plus bx plus c, right? So how do we know what a quadratic graph looks like? Now, the main thing you want to look for when sketching a quadratic graph is if A is positive or negative. If A is positive, that means that the quadratic graph will look like a curve, and it'll look something like this, like a smiley face, you could think of it as. Now, a quadratic will always look like a parabola like this, and it will always have a point that will either be the minimum or maximum point depending on if it's positive or negative. So if A is negative, that means that the graph is going to look the opposite way. So it's still going to be a curve, but it's going to be a sad face now instead of a happy face. And now we've got a maximum point. In this case, we had a low or a minimum point, right? Now we've got a maximum point. So there are ways to calculate these maximum and minimum, and we'll get into those in a second. So how do we find the minimum or maximum of a graph using completing the square? Well, let's say we have already completed the square, right? We've taken our coefficient out, we've completed the square, so we've got x plus p, whatever this value is, p is just a constant, squared, plus q, right? Where q is also just a constant. So we've completed the square, and we've got it in this form. How do we know what the minimum or maximum of our graph is, right? Well, it's simply just a minus p q. So the coordinates are minus pq. So the negative of this number will be your x value, and the positive of this value, or whatever this value is, will be your y value. So let's try an example here, right? So let's say we had y equals x squared plus 2x plus 1. So let's complete the square, right? We take x out, leaving us with x, and then we divide this by 2, leaving us with just 1, and we square this. Then we've got this plus 1 over here, and we're subtracting the square of this, and 1 squared is just 1, so we're subtracting 1, and that gives us x plus 1 squared, and plus 1 minus 1 is just 0, right? So we're basically plussing 0. Now, we've completed the square, right? And looking back at our original quadratic that we had, we see that the coefficient of x squared is positive, meaning that we know we're going to have a graph that looks something like this, like a smiley face, right? Because we have a positive coefficient. So now how do we find the minimum point of this quadratic? Well, we know that we're looking at p and q, right? So this is our p and this is our q, and since we want minus pq, well, minus plus 1 is just minus 1, and 0 is just 0. So this is our minimum point. So that means that our graph is going to look something like this, where this point is minus 1, 0, because it'll be minus 1 on the x-axis, along the x-axis, and because there is no y value, the point will be barely touching the x-axis. And that's how we find the minimum point, using minimum or maximum point, or just a turning point, using completing the square. So now let's think about sketching graphs, right? So when you have a quadratic, there are 3 scenarios. You've either got 2 real solutions, you've got 1 real solution, or you've got no real solutions. When you've got 2 real solutions, your graph is going to cross the x-axis at 2 points, where the points where it intersects the x-axis are your roots. When you've got 1 real solution, your quadratic is going to look something like this, where it touches the x-axis but it doesn't ever cross it, meaning you've only got 1 point where the line and the x-axis meet. In this case, you've got 2, right? Which means you've got 2 solutions. And when you've got no real solutions, that means your graph does not touch the x-axis at all, and it's probably going to look something like this. And if you've got the negative versions of that, the 2 solutions would look something like that, where they meet over here. The 1 real solution will look something like this, where it meets at where it meets at 1 point over here. And then your 0 solutions will, of course, not touch the x-axis at all and look something definitely not like that, or that, something like that, where it will not meet the x-axis at all. So that's something important that we need to know when sketching graphs. So let's actually sketch a graph, right? So the points that we want are the x-intercept, we want the y-intercept, or sorry, x-intercepts, intercept or intercepts, because we could have two real solutions, one real solution, or we might not even have any x-intercepts if we have no solutions. We want the y-intercept, which is where it intercepts the y-axis, and we want the turning point, or the minimum or maximum, right? Depending on if it's a positive, if the coefficient of x is positive or negative. So in this case, it's positive, meaning we're going to have a happy face, which means we're going to have a minimum and not a maximum, right? So let's start by finding the x-intercepts. To find the x-intercepts, we just want the roots of the quadratic. And one way to think about it is, because we've got y equals x squared minus 5x plus 4, you can say that y equals 0, right? Because when y is 0, that's where you are meeting the x-axis, right? When y is 0. So you're letting y be 0, and then you're basically finding the roots of this quadratic, which in this case, we've got x minus 4, x minus 1 when you factorize this out, because minus 4 times minus 1 is 4, and minus 4 plus minus 1 is minus 5, which means that x is, so let's solve, we've got x minus 4 equals 0, so x equals 4, and then we've got x minus 1 equals 0, so x equals 1, so that means that x equals 1 and 4, right? So now we've got our x-intercepts. Now, how do we find the y-intercept? Well, we simply do the opposite of what we did. In this case, we subbed in 0 for y. Now we're subbing in 0 for x, because that's how we find where it intercepts the y-axis, right? So now we've got y equals 0 squared minus 5 times 0 plus 4, right? And that will simply give you 4, because 0 squared is 0, minus 5 times 0 is just 0, so 0 minus 0 is 0, plus 4, well, 0 plus 4 is just 4, so the y-intercept is 4. Now we want to complete the square to find the last bit of data that we need, which is the turning point, right? So we've got x squared minus 5x plus 4, x squared minus 5x plus 4. So let's complete the square. This we divide by x, and we divide this by 2, so 5 over 2 whole squared plus 4 minus the square of this, which is 25 over 4, so minus 25 over 4. So we've got x minus 5 over 2 squared. Now 4 minus 25 over 4 will give you minus 9 over 4. And that means that our turning point is, well, the negative of this and this. So that means we've got plus 5 over 2, because the negative of minus 5 over 2 is plus 5 over 2. And then this is just minus 9 over 4. So this is our turning point. So now we want to sketch this graph, right? So we know that the y-intercept is 4. So let's put that over here. We know that the x-intercepts are 1 and 4. So let's say that's 1 and that's 4. And we know that the turning point, minimum point, is 5 over 2, which is 2.5. And minus 9 over 4, which is minus 2.25. Right, so this is our turning point. So let's say that's around about here. right? And then we simply draw a line through it. Oh my god, that is a bad line, sorry. And maybe if I was actually good at drawing lines, there we go. We draw a line, a curve that goes through all of those points. Now it doesn't have to be exactly precise because obviously you don't know every single point on that curve, but that's why it's called a sketch. And then we want to label these points. We know that this is 4, we know that this is 1, we know that this is 4, and we know that this is 5 over 2 minus 9 over 4. And that's how you sketch a graph. You want both of the, or all of the intercepts, the x-intercept and y-intercept, and you want the minimum or maximum, or just the turning point. And that's how you sketch quadratic graphs. So let's move on to 2.5, which is the discriminant, right? And first things first, we're going to look back at the quadratic formula. So x is equal to minus b plus or minus square root of b squared minus 4ac equals, or over 2a, sorry. Now, which part of this is the discriminant? Well, it's everything under this square root symbol. So the discriminant is just b squared minus 4ac. Now, why is this important? Well, this is what determines if a quadratic will have 2 real roots, 1 real root, or 0 real roots. And how do we know that? Well, if the discriminant is positive, so if this b squared minus 4ac gives you a positive number, that means you will be square rooting a positive number, right? And that will give you a real number, right? Now, if this gives you 0, then you're just simply square rooting 0, which will give you 0 no matter what, right? When you square root a positive number, you will get a positive and a negative number, right? So that means that you could have 2 values, which means that we'll have 2 real roots, right? We could have a positive number and a negative number, which will give us 2 real roots. When we square root 0, we simply have 0. There's no positive 0, there's no negative 0, it's just 0, which means we'll only have 1 real root. But when we've got a negative number, when b squared minus 4ac equals negative number, that is going to give us an imaginary number, which is not a real number, which means we're not going to get any real roots, right? Which means when this is negative, we're going to have 0 real roots. So when this is positive, we've got 2 real roots. When this is 0, we've got 1 real root, and when it's imaginary, or sorry, when it's negative, we've got no real roots. So let's look at some questions now using the discriminant. So let's look at a question here, right? Find the values of k for which f of x equals x squared plus kx plus 9 has equal roots. What this means is basically 2 roots that are equal to each other, which basically means we're looking for 1 root. So using the discriminant, we know that b squared minus 4ac, when we're looking for 1 root or equal roots, that means that b squared minus 4ac must be 0, right? So in this case, what is our b, our a, and our c? Well, our a is just 1 because the coefficient of x squared is just 1. Our b is k, and our c is 9. So let's sub all of that in. We've got k squared minus 4. Our a is 1, and our c is 9, which equals 0. So k squared minus 4 times 1 is 1, 4 times 1 is 4, and 4 times 9 is 36, which means we've got minus 36 equals 0. We add 36 to both sides, giving us k squared equals 36. And then we root both sides, giving us k equals plus or minus 6. Now, be careful with this because remember that when we're square rooting a number, so in this case 36, we're going to have a positive and a negative. So because both positive 6, when you square it, you get 36, and negative 6, when you square it, you get positive 36 as well. So we've got two solutions, and these are the values of k where this quadratic has equal roots. So now let's look at a slightly different question. Find the range of values of k for which this quadratic has two distinct real solutions. So again, we're using the discriminant, and in this case, the discriminant must be greater than 0, because any positive number that if the discriminant is a positive number, that will give us two distinct real solutions, right? So we're looking for when it's positive than 0. So let's sub in our b, a, and c. So b is 4, so we've got 4 squared minus 4 times, well, a is 1, and k is our c, so we've got k is greater than 0. So 4 squared is 16, minus, well, 4 times 1 is 4, and 4 times k is 4k, is greater than 0. Then we've got 16 is less than 4k, because when we're moving this over, when we move the variable over, and we need to flip the sign. So we've got 16 is less than 4k, and then 4 is less than k, because we divide both sides by 4, which means that k is greater than 4. All I've done is just swap the sides and swap the sign. So k is greater than 4. So this is the range of values for when this quadratic has two distinct real solutions. So when k is greater than 4, so let's say k is 5, k is 6, k is 4.2, any value of k that is greater than 4 will mean that this quadratic will have two real solutions. And yeah, that's basically how you use the discriminant. If it said find the range of values of k where it has no real solutions, we would use b squared minus 4ac is less than 0, because any negative number means that, or any negative number that we get for the discriminant means that it will have no real solutions, right? So that's basically how you use the discriminant. Finally, let's move on to 2.6, which is modeling with quadratics. Now, modeling with quadratics is simply just using mathematical models to kind of represent real life scenarios. So to give you an example, I'll start with this question here. So we've got our question here. A spear is thrown over level ground from the top of a tower. The height in meters of the spear above the ground after t seconds is modeled by this function, right? So obviously we're going to start with A. Interpret the meaning of the constant term 12.25 in the model. Well, so this function is basically saying that height varies with time. So basically h of t, where h is height. So when you input any time into this function, so let's say you inputted time is 1, right? If you inputted 1, you would the output would be the height at which the spear is at after 1 second of being thrown. That's basically what this function is, right? So to interpret the meaning of the constant term 12.25, we're going to sub in 0 for time. Why? Because this is the moment or the instant at which the spear is thrown. Or you can think about it as where the spear is when it has not been thrown yet. So when we input 0, we get 12.25 plus 14.7 times 0 is just 0, and 0 squared is just 0, and minus 4.9 times 0 is just 0 as well. So 12.25 plus 0 is just 12.25, which means that at 0 seconds, or before the spear has even been thrown, or at the instant it's thrown, the height is already 12.25, which means that the tower must be 12.25 meters tall. Because if the spear has not yet been thrown, but its height is already 12.25, and because it's being thrown from the top of a tower, that means that 12.25 must be the height of the tower. So height of the tower, and that's how you interpret the meaning of the constant term 12.25. Now let's go on to B. After how many seconds does the spear hit the ground? Well, what we want to do in this case is, instead of subbing in 0 for t, we want to sub in 0 over here for height, because we want to find the time at which the height or y value of the spear is 0, because that's when it's hitting the ground, right? So let's do that. So we're basically just subbing in 0 over here. 0 equals 12.25 plus 14.7 minus 4.9t squared. And we're simply just solving for t. So in this case, you can simply use the quadratic formula, where this is a, this is b, and oh, I forgot to write the t here, sorry. This is b and this is c. So you input that into the quadratic formula, and you should get t equals minus 0.679 and 3.68. Now the thing is, only one of these values will be correct, because as it states in the question, t must be greater than or equal to 0, and this is clearly a negative number. So we reject this value and we say that t equals 3.68, which means that the spear hits the ground after 3.68 seconds have passed, or when time equals 3.68 seconds. And that's all you need to do for B. So let's do part C now. Write h of t in the form a minus b t minus c whole squared, where a, b, and c are constants to be found. So in this question, they're simply just asking us to complete the square, right? So let's write the quadratic out. We've got minus 4.9t squared plus 14.7t plus 12.25. So they want us to complete the square, right? So the first thing we need to do is we want to have no coefficient in front of t squared. So we need to divide it by minus 4.9. So we take minus 4.9 out, giving us t squared, as we've taken its coefficient out, and 14.7 over minus 4.9 will give you minus 3t over here. And this 12.25 we are going to leave unaffected. Now we want to complete this square, right? So this minus 4.9 does not change. Then we've got t minus 1.5, because remember, we take t out and then we divide this by 1.5 and we square it. And then we want to subtract the square of this number. So we're subtracting, well, minus 1.5 squared is 2.25. So we're subtracting 2.25. We close the brackets, and this 12.25 remains unaffected for now. Now we want to take this out of the bracket so we can collect it with 12.25, right? So let's do that. And to do that, we need to multiply it by minus 4.9, right? So this t minus 1.5 squared does not change, but minus 2.25 times minus 4.9 will give you positive 11.025. And of course, we still have this plus 12.25. So now we can collect these two together, giving us minus 4.9 t minus 1.5 squared, and 11.025 plus 12.25 is plus 23.275. Now we're basically done with completing the square, but the form is slightly different. They want the constant first and then the square bracket. So we're going to write our constant, which in this case is 23.275 first, and then our bracket, which is minus 4.9 t minus 1.5 squared. And now it is correctly in the form that they were asking for. So that's all we need to do for part C. So now let's do part D. Part D asks, so using your answer to part C or otherwise, find the maximum height of the sphere above the ground and the time at which this maximum height is reached, right? So first things first, let's think of this as a graph, okay? So let's say we had a graph, okay, where we've got our x-axis and our y-axis. Now in this situation, our x-axis is time and our y-axis is height, correct? So let's say the sphere started at 12.25, right? Because that's the height of the tower. And then it looks something like that, where this value is 3.68, which is the time at which it hits the ground, right? So let's say this is what the curve looked like, right? They want to find what the coordinate of this is, basically, right? We want the maximum of this quadratic. So how do we find that? Well, we looked at that previously, right? After completing the square, we know that the maximum or minimum or turning point is minus AB, where this value is A and this value is B, right? So we already have all the information we need by completing the square. When you sub in minus 1.5 for A, you get positive 1.5. And then when you sub it in, when you sub in B, that's just 23.275, which means that this coordinate over here is 1.5, 23.275, which means that the maximum height is 23.275, 1.5 seconds, or after 1.5 seconds of time has elapsed. So this is basically 1.5, because 1.5 seconds has elapsed when we're at this coordinate, and this is 23.275. So it's reached its maximum height of 23.275 after 1.5 seconds of time has elapsed. And that's all you need to do for part D. So that's about it for this video. With modeling with quadratics, it can get a little bit tricky, but after a bit of practice, you will get better at interpreting certain quadratics given to you in terms of the context given to you. Eventually, you'll get the hang of it. But that's all I have for this video. Just make sure you're practicing, and leave any questions in the comments if you're confused about anything. And thank you for watching. Next week there should be chapter 3 out. Hopefully, I plan to get one chapter done every week, hopefully, so stay tuned for that. And thank you for watching this video, and I hope you have a great rest of your day.